Let's make a recap of what we've done so far. We've created a Poetic Coins application which connects to multiple cryptocurrency exchanges via their WebSocket API. The clients receive trades in real time and they broadcast these trades using Phoenix PubSub. A separate historical process receives the trades via the PubSub, keeping the most recent trades in the process state. In this way, we can easily get from the historical the updated prices whenever we need. Everything is supervised and automatically started when the application is launched. To use the application functionalities, we'll mainly use the functions in the Poetic Coins module, which is our public interface. At the moment, the functions are available products, which returns a list of products supported by the application, then subscribe to trades, which subscribes the calling process to the PubSub topic to receive new trades for the specific product, unsubscribe from trades, unsubscribes the calling process from the PubSub topic, and then get last trade returns the most recent products trade present in the historical process, and then get last trades. This product, it's a list of products, and it returns the most recent trade present in the historical process, given a list of products. These functions are not implemented in the Poetic Coins module. They are mostly implemented in the exchanges context and the historical module. We've then briefly seen in the product controller how we can use these functions to get the most recent trades for all the available products and render them into an HTML table. The first goal we now want to achieve is to render a similar page, but this time using LiveView. We'll then see how easy it is to dynamically update the view once new trades come in. In this lesson, we'll only introduce LiveView and get a sense of how powerful it can be. In the next lesson, we'll see better how LiveView works under the hood. So we start by defining our first LiveView module in lib, Poetic Coins web, and inside here, this folder live. So we create a new file called, we can call it crypto dashboard live.ex. And inside here, we define our LiveView module. So def module, Poetic Coins web, because it's the web part, crypto dashboard live. So in this module, we need to implement two callbacks. Well, first we use this macro, use Poetic Coins web LiveView, and then we will need to implement the two callbacks, the mount and the render callbacks. So we are not going too much into detail. We'll see better in the next lesson how these two callbacks are part of the LiveView's life cycle. But so by now, we just need to know that a LiveView is a process, and each connected user is served by a separate LiveView process. The mount callback is the LiveView entry point. Here is where we initialize the state when a user connects. And the render callback is responsible for returning the rendered content. So we first implement the mount callback. We ignore the first two arguments. So the first is params, the user parameters, then is the session, and the third is the socket, which is a Phoenix LiveView socket. So we can add key value pairs to the socket using an assign function. We can then refer to these pairs, these key value pairs in the views template. So here, remember, mount is the entry point, and we start just one product, and we want to show the last trade of this product. So we can, so the product, we alias poetic coins product, and the product can be one of the most traded, so Coinbase BTC USD. And then we get the last trade with using the poetic coins context, get last trade for this product. And with the assign function, we assign this trade to the socket. So we use assign, and the first argument is the socket, the second is the key, and the third is trade, this trade, and it returns the new socket. So this assign function updates the socket assigns map, and then we return OK and the new socket. So we can now use this trade in the trade key in the template. We can now implement the render callback. At the moment, we'll just render the last Coinbase BTC USD trade details. So the render callback has one argument, which is assigns. So these assigns are the socket assigns. And inside the render function, we can use the L sigil to inline LiveView templates. At the beginning, especially when playing with small views, it's pretty useful to have everything in one module. So it's useful to have the template inside here. We can also have the template in a separate file. So, like the classic EEX template, we refer to the assign trade using the trade with the @trade key. So we can print, well, the product, trade, product, exchange name, and then the currency pair, maybe currency pair, then the trade information, so like trade, traded at, the price, and the volume. The view is ready. We just need to update the router. So we go in router, and inside here, you see that initially we got this live route. We can do the same thing. So we comment this get route, and we add our live route, which points to the crypto dashboard live view. So before running the server, something to notice is that this trade could be nil. So we don't handle the fact that this trade could be nil. The product is quite traded, and the historical should have a trade almost immediately, but this is something to consider. So we run our server and we see our view. Okay, so it was simple, and but obviously this is like the same result we got with the controller. It doesn't update. So let's go back to our module and let's see how to handle new trades. So first, to get new trades, we need to subscribe to the pub subtopic. So to subscribe to the pub subtopic, we use the Poetic Coins, subscribe to trades, product. We need to add an if condition. We will see in the next lesson why we need this if condition. So socket connected to. So if the socket is connected, we subscribe. And then remember that LiveView, this LiveView is a process. So it will receive messages from the pub sub, and to handle the messages, we implement the handle info callback. Handle info. So the message, remember, is new trade, and we get the trade. So this trade will be a Coinbase, it will be a new trade for the Coinbase BTC USD product. And the second argument is the socket. So what we do is to update the trade in the socket. So we socket, we assign this new trade. So socket, trade, and the trade. So again, the assign function. So the first argument is the socket, and we assign this new trade, and it returns the new socket. And what we do is to, this time, the first element of the tuple is no reply, and the new socket. So every time we change something, we change the socket, the assigns in the socket, the view is re-rendered, and the changes are propagated, are sent to the browser. And the browser, the LiveView part, the JavaScript part of LiveView that is running in the browser applies the changes. So we just need to change the state to apply the updates. So with just these 4 lines, I would say 1 line of code, we handle the new trades. We refresh the browser page, and we see that it changes automatically. So we get the new trades, and we didn't have to do anything on the JavaScript side. So this is pretty fantastic, because here in this way we just need to focus on the data, and every time we change the data in the process state, in the assigns, the changes are propagated automatically to the browser. Great. We now want to render a table with all the products and see the new trades for all the products. So we need all the products, not just Coinbase. So products, so Poetic Coins, all the available products, and then all the trades. So the trades, Poetic Coin, get last trades for all the available products. So it's useful to convert this trades list. This is a list of trades, and some element could be nil. For example, if the historical doesn't have any trade for a product, that element of the list will be nil. So we need to convert this trade to a map. We will see why this is going to be useful. So to do so, we do get last trades returns a list of trades, and then we want to convert this list of trades to a map. So first we reject all the nil values. So we reject the element when it's nil. Then we map the trade to a tuple, two-element tuple. In this way, we can create a map using enum. So the first element is the key, so the product, and the second element is the value, the trade itself, and we use enum into an empty map. So this will inject these key value pairs into a map. So this trade is now a map. Now we want to subscribe to trades, but for each product. So what we do is enum each products. So for each product, we subscribe to get new trades. And here we assign, instead of trade, the trades map, but we can pass a keyword list, so trades, the trades map, and we also assign the products. The reason why we also need the products, because in trades we also have, inside the trade we also have the product, but here we have, this is a list of products which is ordered. So when we enumerate, the order will always be the same, and this doesn't apply to trades because it's a map. So we can now remove this template, and we can just copy and paste the template we had in the index view. And this for loop is a little bit different. So first we enumerate the products. So for each product, we want to have a trade. So we want to render the trade. So the reason why we use equal is because in this case, we use this arrow symbol because we want to enumerate. In this case, we use equal because we just need to get the trade from trades using the product key. Then, when we receive a new trade, we need to update the trades map. So instead of using assign this time, we use update, which is pretty similar to the map update function. The first argument is always the socket, then the key, trades, and then a function to update the value. So we get the trades, and we want to update the trades. So we use map put trades, the key, which is trade product, and the trade itself as a value. So map put returns an updated map. Update returns an updated socket, and we then return the updated socket. This can be a little bit more compact. Like this. And in this way, we don't even need this alias at the moment. Let's recap. We get all the available products, we convert the trades list, the trade list into a trades map where the key is the product and is a product and the value is the last trade for that product. Then we subscribe to the trades for each product, and we assign the products list and the trades map to the socket. So we return the updated socket. Our render function, so the template is our table, and we enumerate the products, and for each product we get the trade from the trades map, and we filter out all the nil elements. This can happen at the beginning when the historical is not fully populated yet. And then our handle info now uses an update function which updates the trades map with the new trade using the trade product key and the trade as the value. And just by refreshing the page, we see a table with all the products that gets updated automatically every time the app receives a new trade. I think it's pretty fantastic. I know this seems magic, but in the next lesson, we'll see in detail how LiveView works under the hood and its life cycle.